Welcome to LIB Academy once again. This is a continuation of gamma function problems, and this is a case that where we have looking at the general gamma function formula. We have gamma n equal integral from 0 to infinity x to the power n minus 1 e to the power minus x dx. But in these problems, the power of e is not minus x. We have some terms attached to the power of e that we have to work on so that we get a term which is of the form e to the power minus x before we can evaluate our expression. So without wasting much time, let's start. So what we are going to do is that we have to let 3x here equal a variable. So let's say u equal 3x. In doing this, don't add the minus sign to it because we need the minus sign here. We need the minus sign to be there. So u equal 3x, and we therefore solve for value of x. So we know that u equal 3x. So u equal 3x. If we want x, just divide both sides by 3. So we mean our x here is going to be u on 3. So we need this value. And we also need the u. The u equal differential of this. So 1 by 3 is going to give us 3 dx. So we need this. So now we replace u, we substitute the values of u into the equation again or into the problem again. So let's make our substitution. So integral from 0 to infinity x to the power 6 e to the power minus 3x dx. We know our x to be u on 3. So this is going to be u on 3 all to the power 6. And our 3x to be u. So e to the power minus u. And the x here, we have to make the x the subject. So making the x the subject right here, we have the u equal 3 dx. So we just divide both sides by 3. So our dx is going to be du over 3. So this dx right here is going to be replaced by du over 3. So here we are going to get du over 3. So we have to simplify this further. This right here is the same as integral from 0 to infinity. We can get 1 on 3. This expression, you see, u multiplied by 1 on 3 is the same as u on 3, right? So 1 on 3, but we have a power 6 that is affecting the 3 here. So power 6, and u is just there. So u power 6 and e to the power minus u. And this over 3 here, we can is the same as 1 on 3 multiplying the u. So we can just isolate this here. So 1 on 3, then we bring our du here. So going further, 0 to integral from 0 to infinity 1 on 3 to the power 6. You can bring this 1 on 3 here, 1 on 3 here to the power 1, right? And u here to the power 6, e to the power minus u, then our du. So from indices, you can see that you can just add these powers. We have a term which has the same base. Yes, so we can just add the powers, which is 6 plus 1, giving us 1 on 3, integral from 0 to infinity 1 on 3 to the power 7, u 6 e to the power minus u du. So we can factorize this whole term out. So 1 on 3 to the power 7, integral from 0 to infinity, remaining u to the power 6, e to the power minus u du. So now you can see that this expression right here is similar to this, because looking at exponent of e, we have minus a term, no other variable attached to it, and these are n minus 1 here is of the form this. So we can now go ahead and equate the exponent of u to exponent of x right here to look for our n, because we want to know the value for our n so that we can just take gamma of n, and the only way we can get the value for n is to equate these powers. So we have n minus 1 equal 6. So n equal 7. You could see that it means our n here was 7, and it was reduced by 1 to give to and remaining 6. So now we can go ahead and find our gamma n, which is gamma 7. But notice that a whole of this here is gamma 7. So multiply by 1 on 3 power 7. Whatever you get here is going to affect the gamma 7, apart from the expression from this expression. So, and we know that gamma 7 multiplying 1 on 3 to the power 7. Gamma 7, we can use this formula to simplify gamma 7. Gamma n plus 1 equal n factorial. Since it is not a fraction, we use this formula. So we have to break this 7 here in a form gamma 6 plus 1, which is the same as 7, multiplying 1 on 3 all to the power 7. So gamma 6 on 1 is the same as 6 plus 1 is the same as 6 factorial. Comparing this to this formula. So 6 factorial multiplying 1 on 3 to the power 7. And 6 factorial is 720 multiplying 1 on 3 over 7. So let me just point this one on my calculator. This will give me 80 on 243. This is our final answer for this problem. So question number 2, like we did earlier, our main focus is compare this to the general gamma formula, 0 to infinity x to the power n minus 1 e to the power minus x dx. But in this case, we can't just go ahead and equate the powers of x right here and solve for n, because the exponent of e here is not in the form of minus x. We have something attached to it, so we just have to do something, and this is using the substitution method to simplify the expression. So we can let u equal x squared, not minus x squared, because we'll be needing the minus sign there. So if u equal x squared, we will also solve for value of x, for the value of x. So u equal x squared. If I should square both sides, then my x should be equal to square root of u, right? And then we also need to find the x. So we know that du equal 2 by x and the power of decrease, remaining 1. So just leave it that the x, right? So we need x, so we can divide both sides by 2x, 2x. So we are going to get the x to be equal to du over 2x. So we need this one right here. These ones right here, we need them. So now let's do our substitution now. We are substituting into this. So we have integral from 0 to infinity x squared e to the power minus x squared dx. And we know our x to be square root of u. So e to the power infinity square root of u, our x is square root of u. So square root of u all squared, and then e minus our x squared is u. So u, and then the x right here is du on the x, on 2x. And we know the value for x to be square root of u. So instead of du over 2x, we are writing du over 2 square root of u. So du over 2 square root of u. So now let's go ahead and simplify this. This one here, we can rewrite it in this form. We know that square root of u squared, this will just cancel out. We will left with u. E to the power minus u. This one we can just write it in the form du multiplied by square root of u multiplied by du. Can we bring half outside? You will see this one is also the same as, that is how I write my infinity is not 8. U e to the power minus u multiplying half multiplying 1 over du, 1 over root u du. This term here is just the same as this. If you use to multiply this again, you will get the same thing here. So that means that we can just group these terms so that we can have square root of u at this side. So it should be like this: u over square root of u. Multiplying our half, we can bring our half outside here. E to the power minus u du. So now using indices, this one can be written as 0 to infinity. We have this one e to the power 1 Square root of u is the same as u to the power half. So we are bringing the half up, so it's the same as minus half, right? So in indices, if we have 2 to the power 2 over 2 to the power 3, you can represent it by 2 to the power 2 minus 3, right? You can represent it in this form. So that's what we are doing here. So e to the power minus u du. And simplifying the 1 minus half is just half, positive half. Integral from 0 to infinity, u to the power half, e to the power minus u du. So at this point, you can see that this one here is similar to our general um, gamma functions formula, right? We have exponent of e to be just minus a term, and then this one right here. What we are going to do now is to equate the power of u here to x squared here. Sorry, to n minus 1, so that we look for the value of our n here. So n minus 1 equal half, right? So n equal half plus 1. So this will be giving us 3 on 2. Am I right? Yes. So 3 on 2. But don't forget that we said our gamma n equal this. So any term that we get here is going to affect our gamma n. So any value, numerical value in this form is going to affect our gamma n. So we know that our n equal 3 on 2. So our gamma 3 on 2 multiplying half this numerical term, we are going to multiply by the gamma value that we get. All right. If so, this should give us 0 of 0 to infinity x squared to the power minus x squared dx. Because assuming if our half was to be here, at the end of the day, we will divide both sides by 2. And this term is also going to take like 1 on 2, which is the same. So at the end of the day, we just have multiplied this. If we divide both sides by 2, this term is just 1 on 2. 1 on everything here on 2, which is the same as multiply by half. So gamma 3 on 2, we want to express gamma 3 on 2, we want to simplify gamma 3 on 2. And we know that for fractions, the formula that we have to use is n gamma n, right? So we have to express it 3 on 2 in a form 1 plus something giving us 3 on 2, right? So to do that, we can just equate this. So n plus 1 should give us 3 on 2. So solving n, you see that your n will give you half, which means that half plus 1, gamma 3 on 2 is the same as gamma half plus 1, right? So this means we can represent gamma 3 on 2 by gamma half plus 1. So this will be giving us so our gamma 3 on 2 multiplying half is the same as gamma half plus 1 multiplying half. And looking at this, we can compare it to the formula here. We have our n to be this one is half. Comparing this to this formula, we have gamma n plus 1 equal n gamma n. So our n here is half. So we are going to have n gamma n, which is half gamma half multiplying by half. So gamma half is just a constant, which is square root of pi. So let me rearrange this: half multiplied by half gamma half. Gamma half is just square root of pi, so half by half is just the same as 1/4 square root of pi. So which is going to give us square root of pi on 4. So that is it for this problem. You can try this and let me see your answer in the comment section. So it's just like you can't just use it straightforward. You have to use substitution method to substitute something you call, let's say, a variable equal u equal 8x, not negative x. Then you find the value for the x and you also make x a subject. When you're done, you substitute those values in this and you simplify it further up to a point where you get a term which is similar to the general gamma functions formula. So integral to infinity x to the power n minus 1 minus x dx. If you get to a point that you get something like this, then you are good to go to compare exponents. Then look for your gamma and simplify it. So thank you for watching. See you in my next video.